Aeronautics is now exploring how they can introduce the technology safely into the aircraft. Passenger transport is way too important, so it needs to be safe.
Well, it is used in different several ways. As I mentioned in the conference, we have applications with a lot of mechanical needs that are very complex, and we also have some others which don't have that complexity and can also be used. So then there is different technologies for each of one, and it's just trying to find the correct one.
It's used more and more, mostly for high-end parts, but it's going to be used in, let's say, in broader way in the near future.
We are using metal printing, and we use EBM technology for it. So it's electron beam melting. It's a powder bed system, which we see for titanium has big advantages.
We rely with a lot of technologies, powder-based with the laser and also with the EBM. But we are exploring other new modalities like ED.
We use the SLM. In this case, we are using a Renishaw machine, A400.
We rely on different technologies. We have additive technologies for additive manufacturing technologies for metals from SLM, and then we also have for plastics, multi-jet fusion and FDM, and then we also have stereolithography for resins.
Mostly SLS and, let's say, in general, powder-based systems.
Additive manufacturing, what you can do is reduce the casting time or completely avoid the casting time, having faster development times.
I guess the main factor is to have an increased characteristics to be able to have more loaded parts, but also programmatic aspects to be cheaper, to be more cost efficient, and to have less lead time.
The AM in aeronautics has the chance to change the design, to change the product, to change the mentality of the OEMs in this case for aero engines that we are focused.
Improving performances, making lighter and also more cost effective. So it's really a revolution for us.
We are producing for aerospace mainly, so we need to be ready for the future when our customers come to us and want parts which start from a printed component. Otherwise, we lose half of our business.
It gave us the opportunity to present our experience on additive manufacturing, exploring new technologies that are coming in the market and see if we can leverage on with respect to our business.
It is important because we can show what our idea is and how we think that the space industry is going to change in the next years.
Well, it is very important because it's putting into the public stage different technologies and different alternatives, not only for additive manufacturing, but also for robotics and industrialization. It is a very complex question. What we can see is that there is certainly a need or a request for bigger manufacturing machines, but there is also a lot of need for different materials. So there is a lot of research to be done within the next 10 years.
So especially in the space industry, I see a redefinition of the whole design concept of spacecraft, meaning that we might rethink completely the way how a spacecraft is built.
I think that in 10 years there will be more products that will be produced in series with additive manufacturing.
In 10 years, I think it will be way more integrated into the design offices. We think that the development of software auto-creating parts will help the developers a lot to create printable parts that just can be sent to a company specialized in printing.